find the arc length of the graph of x equals y to the 2/3 for y's between 1 and 8. So we're given a function x as a function of y, and so because of that we should use the formula for arc length that is in terms of y. And if that becomes undoable, then maybe we can switch, and if it's possible, solve for y in terms of x. But let's go with this version where we have x as a function of y. First step is to find the derivative, square it, and add 1. So if x is y to the 2/3, the derivative is 2/3 y to the negative 1/3. A better way to write that before squaring it would be 2 over 3y to the 3rd. Alright, great. Taking the derivative. Now let's square it. So we multiply it out by itself. What we end up with is 4 in the numerator, 9 in the denominator, and then y to the 3rd times y to the 3rd is y to the 2/3. So if we squared it, took the derivative and we squared it. Now we need to add 1. And when we add 1, we need to simplify it. If we have these two terms, it's best to write this as one single fraction. So rename 1 to be 9y to the 2/3 over 9y to the 2/3. This is part of simplifying before taking the square root. Okay. So combine these into a single fraction as part of simplifying. So now we're ready to take the square root. Square root of a fraction is the square root of the numerator divided by the square root of the denominator. In the denominator, though, we have a perfect square. The square root of 9 is 3, and the square root of y to the 2/3 is like having y to the 2/3 and then that raised to the 1/2, and you can multiply the exponents together and the 2's would cancel, and that's how you end up with y to the 1/3. The numerator, please don't fall into the trap thinking that you can take the square root of each of these. No, not with the plus in between. With the multiplication in between you can, but not with the plus in between. So we just leave it as exactly what the numerator is with the square root. Okay, so now we're ready to integrate. The y limits were from 1 to 8. And so what we can do is pull the 1/3 outside and then focus on what's underneath the square root. For that, we could do a u substitution. Its derivative will involve the y to the 3rd as a negative exponent, negative 1/3. If u is equal to 9y to the 2/3 plus 4, then du is 9 times 2/3 y to the negative 1/3 dy. The 3 can cancel the 9, and so you'd end up with basically a 6. And the y to the negative 1/3 can be put on the bottom as a y to the positive 1/3. And so ultimately, this is what we have for the other part of the integration. The 6 we can just divide by it. So this will take the place of dy over y to the 3rd. Taking the place of the root will be the root of u, or call it u to the half. Don't forget that you had the 1/3 outside too, so altogether 1/18. When you find the integral of u to the half, you get u to the 3/2 times 2/3. This 2 can turn this 18 into a 9. So altogether we have u to the 3/2 over 27. All of this is side work for us to figure out what the antiderivative of our current integral is, and we found it. It's 1 over 27, whatever u was in terms of x on y, to the 3/2. So 9y to the 2/3 plus 4 to the 3/2, the entire quantity to the 3/2, and that's from 1 to 8. So now it's our job to put an 8 in and put a 1 in. Fundamental theorem of calculus says we can then subtract. So we put the 8 in place of y. We get 8 to the 2/3. Now 8 to the 2/3 can be thought of as 2 cubed to the 2/3. And these guys can cancel again like before. And we have 2 squared. So that's just a 4. So 9 times 4 plus a 4, that's 36, plus a 4, that's 40. When you put the 1 in, you end up with 9 plus 4, so that's how you get the 13. And so 36 plus the 4, that's how you get the 40. And there's nothing else you could do with that. Leave your answer just like that. 40 to the 3/2 minus 13 to the 3/2. All of that quantity is times 1/27. That would be the arc length of that function between y equals 1 and y equals 8.